The Apollo 13 mission, NASA's third crewed mission intended to land on the Moon, launched on April 11, 1970. Despite its ambitious goal, Apollo 13 is best remembered as a successful failure due to the incredible challenges faced and overcome by the crew and mission control. Crew and objective of the mission was commanded by James A. Lovell, with John L. Swigert as Command Module Pilot and Fred W. Haise as Lunar Module Pilot. Their objective was to explore the Fra-Maura region of the Moon, conducting geological surveys and experiments. The mission's secondary goal was to further demonstrate and validate NASA's ability to safely land humans on the Moon and return them to Earth. The incident on April 13, approximately 56 hours into the mission, an oxygen tank in the service module, SM, exploded, causing a cascade of failures. The famous phrase, "Houston, we've had a problem," was uttered by Jack Swigert and later repeated by Jim Lovell as they reported the crisis to Mission Control. The explosion led to a loss of electrical power, water, and oxygen, making a lunar landing impossible and threatening the crew's survival. Causes of the explosion was traced back to a combination of design flaws and procedural oversights. Oxygen tank fault. The tank had been damaged during pre-launch testing. The heater inside the tank had a thermostat rated for 28 volts, but it was exposed to 65 volts, causing the insulation on the wires to melt. Stirring mechanism. The tank's internal fans, used to stir the cryogenic oxygen, ignited the damaged wiring insulation, leading to a catastrophic explosion. Immediate response. The crew quickly adapted to the crisis with the help of Mission Control in Houston. Key steps taken included shutting down the command module. To conserve power and resources, the command module, CM, Odyssey, was shut down, and the crew moved into the lunar module, LM, Aquarius, which served as a lifeboat. LM lifeboat strategy. The LM, designed for 2 astronauts for 2 days, had to support 3 astronauts for nearly 4 days. This required careful management of resources like water, oxygen, and power. Course correction and return journey. The primary challenge was to plot a safe return trajectory to Earth. Key maneuvers included free return trajectory. Initially, the spacecraft was placed on a free return trajectory, ensuring that if no further maneuvers were made, the spacecraft would loop around the Moon and return to Earth. PC+2 burn. After rounding the Moon, a critical burn, pericynthion +2 hours, was executed to adjust the return path. This burn was performed using the LM's descent propulsion system, ensuring the spacecraft would re-enter Earth's atmosphere at a safe angle. Re-entry preparations. Before re-entry, the crew had to power up the CM from its dormant state, a complex task meticulously planned and executed to ensure all systems were functional for the critical re-entry phase. Life support management. The crew faced severe challenges in managing life support systems. Carbon dioxide scrubbing. The LMCO2 scrubbers were not sufficient for 3 astronauts over an extended period. Ingenious engineering by ground control led to the creation of a makeshift adapter, using materials on board to fit the CM's lithium hydroxide canisters into the LM system. Water and food rationing. The crew rationed their limited water and food supplies, enduring cold temperatures and dehydration to ensure survival until re-entry. Re-entry and splashdown. The crew successfully transferred back to the CM shortly before re-entry. On April 17, 1970, after jettisoning the service module and lunar module, the command module re-entered Earth's atmosphere and splashed down in the Pacific Ocean, where the crew was safely recovered by the USS Iwo Jima. Legacy. The Apollo 13 mission is celebrated for its demonstration of human ingenuity, teamwork, and the resilience of both astronauts and ground control. The incident led to significant changes in spacecraft design, testing procedures, and emergency protocols, enhancing the safety of subsequent missions. In summary, Apollo 13's story is not merely one of failure but a testament to the extraordinary efforts of NASA's engineers, scientists, and astronauts, turning near-certain disaster into a remarkable tale of survival and problem-solving.